My name's Christopher Godself, and I'm going to be bringing you Learn to Build Computer Programs on a Microsoft Windows Computer. A rather vague title, but you can see it's a whole series of video shorts. By short I mean, roughly speaking, quarter of an hour, and that's my name, Christopher Godself. So, what can you tell by looking at me? I like hats and a snazzy shirt. You can also tell, probably, that I'm not too healthy and I have some kind of a lung problem. In fact, that's pulmonary fibrosis. So I'm going to sound a bit short of breath throughout all of these videos. What you can't tell by looking at me is that I did a PhD in physics a long time ago, and I have a lot of experience in scientific and numerical programming over the years. All of that was on Unix operating systems, and when I got my own personal computers, as they used to be called, I would install Linux. However, here you can see I haven't done that in this case, and the reason is I'd like to migrate a lot of the software that I've written so that Microsoft Windows users can use it. And really that's been the inspiration for all of these videos. Now here I am on my Microsoft machine. Well, some of you will recognize instantly that this is a detail from The Garden of Earthly Delights by Hieronymus Bosch. I'll just bring this up for you. There we are, a Wikipedia page on this famous triptych. We have Adam and Eve, lots of cavorting early humanity, probably before the flood, and the hell that awaits cavorting humanity. So this third panel is devoted to hell, and you can recognize this chap here from my background. So why have I got hell as a background? Well, I suppose it's because most Linux and Unix people regard Microsoft as a form of hell. However, I must say, I started to learn to use some Microsoft stuff in about April of this year. That's 2019. It's now November, and I must say I haven't found it that hellish after all. So perhaps purgatory would be better, and anyone who knows Unix would say that Unix is purgatory too. Let's have a look at my Windows setup here. We have games in DOSBox. These are DOS games such as Tomb Raider 1 and Prince of Persia, and a couple of slightly more modern games, but still quite ancient. Anyway, that's the important stuff. Next is the command tool for Microsoft Windows, which I've pinned to the desktop. Vim, Linux people will like that, Microsoft people will not, but everyone will like OpenOffice. You get all the Office stuff, and you don't have to spend a fortune on Microsoft Office. Unix people will love to see things like GIMP and GAMP and Inkscape on graphics. FileZilla is for transferring files between computers. They can be heterogeneous, in other words, Microsoft to Unix, Unix to Microsoft, or they can be like Microsoft to Microsoft. PuTTY is connecting to other machines. This is for X Windows. The Unix people will certainly want those. That's my little recording device that I'm using. What else can I say? Oh yes, there's Cygwin, which opens a Unix kind of command line, which again Unix people will like. Microsoft people will want to avoid that. But if you are a Unix Linux person, let's go back to Cygwin. You can rerun the setup program for Cygwin anytime and install loads of extra software that will run under Cygwin in a Linux kind of environment. So for instance, one of the things I downloaded when I reran the setup file for Cygwin was Xfig, and the way you run stuff is you have to, that opens Windows, that is, you have to export display equals colon 0.0 and do xhost plus, and then Xfig runs fine. If you want to use Cygwin to launch any X Windows stuff, you really have to install these X Windows things and be running your X server, otherwise you'll just get can't open display. So here we are right back at the title page, and the first thing to notice is that it says learn to build computer programs, the emphasis being on build. The reason is that these videos really aren't about programming as such, but assuming that you have some kind of computer language already, and it's how to actually build executable files out of the programs that you've written. And not just executable files, but archives and libraries. When I say a computer language, I mean a language that you actually have to have a compiler for, rather than a scripting language. So C and Fortran are like that. You type in all your programming statements into a plain text file, nothing to do with OpenOffice or Microsoft Office or anything like that, just a plain text file that only contains the bytes of the characters you type in and no formatting information. When you've got your program, you have to run it through a compiler. Things like Perl are not compiler languages. So C is a compiler language, and C++ and Fortran and Ada and so on. So I'm emphasizing the fact that I'm not going to try and teach programming or any programming language. We will come across examples, very simple hello world type of examples, but I'm certainly not going to attempt to teach anything to do with languages. It's how to build bigger programs out of smaller ones once you know your language. So an experienced programmer will, instead of typing in all the program into a huge file, into one sort of homogeneous mess, they'll split the code up into chunks called functions usually. Of course, all those functions can go in a single file, but the best thing to do is to split those functions up into separate files. Once you've done that, you can use the compiler to act on each little chunk and then link them all together into one big program at the end. And of course, as I said, we want to build libraries of code that can be accessed by lots of other computer programs as they need the library functions. When I say the stuff here, I mean things like compilers. We're going to use free compilers, or compilers that you can have free versions of. For instance, we don't want you to actually have to fork out any money to actually learn this stuff. So I mentioned earlier on that my background was in numerical computing and science and engineering, but you might think that's not for you. You don't have to be a maths genius to use library code written for you. You do have to understand the problem, but the point is, if you've got, whether it's a numerical problem to solve or a completely different kind of problem, let's say graphics, for instance, how do I draw a triangle on the screen? You don't have to be a computing genius or a maths genius. There are libraries out there that you can download for free. In the case of graphics, it will be OpenGL. They should be simple enough to use. Just follow the instructions very, very carefully. For numerical software, my port of call is always GAMS. So here we are at GAMS, Guide to Available Mathematical Software, and you can download all kinds of stuff, including whole libraries of things, or you can download separate things and build them into libraries if you want. Let's have a look at problem taxonomy. So for instance, you might come across problem in approximation, and here we are. Least squares, approximation, minimax. You can download software for all of these things. Least absolute value. Let's click on that one. And here are the names of routines that actually do exactly that. So you don't have to know much. You don't have to solve the problem yourself. You don't have to reinvent the wheel. But for instance, these are Fortran routines. A lot of libraries, especially mathematical ones, are in Fortran, and so I do give some Fortran examples. That's one source of software that you might want to download libraries from. Tom's is a whole library of programs, for instance. Another one is OpenGL for graphics, which I think I mentioned. There we are. That's the OpenGL software development kit, getting started. There's all kinds of libraries and utilities here, for instance. And Wikipedia will give you a very good overview. Anyway, as you saw already, when it comes to numerical stuff at least, and scientific computing, a lot of stuff that you'll find in libraries or standalone programs will be written in Fortran. We shall concentrate our building of programs on Fortran, or calling Fortran from C and things like that, rather than just using C or C++, as probably most people do. Fortran is not available in Microsoft Visual Studio. I'm not telling you to learn Fortran. What we're going to do is learn how to be able to call Fortran functions from programs written in other programming languages. As I said, the idea is that we can split our program into different functions in different files, and indeed those functions can be written in different programming languages, and they can still all call each other. We'll see how to iron out any problems that we encounter. So, the emphasis is on compiling, linking, and building libraries. I'll explain all of that later. Oh, and most people who write programs like to use things called interactive development environments, or IDEs. We'll have a look at some of those later, though most of what we will do will be using the command line. Don't worry about that, you'll soon get used to it. So, who's the intended audience? Well, I may as well couch things for absolute beginners, even though some of them might be people who are wanting to port software to Microsoft Windows from Linux and Unix, and Microsoft people who are interested in Fortran compilers, perhaps only because they have some Fortran libraries to compile. That's what all these videos will be about. So our next video won't be dealing with any of that, though. What we'll do is we'll have a video about the basics of using a Microsoft machine. That's for the Unix and Linux people. But of course there's a few hints and tricks that perhaps some even Microsoft people won't know about, especially if they don't use the command line. Lots of people get really worried about using command line and want everything to be point and click, but really don't worry, there's really not that much to it.